Good day, everybody. We're looking for a three-digit natural number. That would be a number between 100 and 999 inclusive. Okay, so we're looking for this kind of n, and it has to satisfy this somewhat complicated nested condition. Now let's write down a couple of the little d is often called tau these days, I think, but just an example. D at 6, and this is related to our problem, equals to d at 8. And again, this is sometimes called tau, the tau function. I'm just using little d. It's a little more, it's an older way of doing it. Some of the older number theory. Underwood, Dudley's textbook, Charles Vanden, Eyndens textbook use lowercase d. Okay. Now both of these, both 8 and 6, have 4 divisors. This only counts them. It doesn't count their magnitude. 6's divisors would be 1, 2, 3, and 6. 8's divisors would be 1, 2, 4, and 8. All right. Now again, this is a nested condition. We're applying the divisor function 3 times, and we're looking for the largest 3-digit integer, such that evaluation will be 3. Okay, so I won't do too much. There's other numbers that would give you 4, like any prime squared would give you. Is it not prime? We need 3. Any prime squared would give you 3 divisors, and so we're doing 4. That's the smallest square prime. Okay. So we need 6 or 8 per this right here. We need d of n to be 6 or 8 based on what I've written up here and just based on the nature of the nesting here. Now, the only 2 patterns I found for 6, we'll do 6 first. We'll do 6 first. Are primes of this form p squared q, where p and q are primes, or p to the 5th. P to the 5th has definitely 6 divisors. 1. P to the 1st, P to the 2nd, PQ, P to the 4th, and P to the 5th. And then here there's a known property of incrementing the exponents and multiplying them. So there's 3 times 2 here, divisors of P squared. And they're easy to enumerate, all right? That's owing to the uniqueness of the prime factorization. So 3 times 2 is 6, 5 plus 1 is 6 right here. Now, this is the first one I thought of right here. Notice that this guy right here is the first one I thought of. It's a pretty large 3-digit number, and it's in this form right here, folks. Okay, it has 6 divisors, and it's 845, so that's getting close to 1,000, right? Now, as far as the 5th power goes, 3 to the 5th is 243, and 5 to the 5th is just greater than 1,000, which is all we need to know, okay? Now, okay, so this is, quote, large, but can we find a larger number? Okay, well, let's see. The one that I looked at, I think. Now, y'all, one way to motivate this is to just think of 1,000. Okay, 1,000 is equal to 50 times 20, right? But notice that the number I'm writing down right underneath it is less. 49 is certainly less than 50, and 19 is certainly, make sure that dot's prominent there. We're multiplying these numbers, folks. Okay, so this is 19, right? So you see, we're looking for a number smaller than 1,000, and 50 times 20 is 1,000, so 49 times 19, but hey, that's 7 squared times 19, okay? And that number is equal to 931. Okay, so you see we're bigger than the 845. Now at this stage, I thought I was done with the problem. I go, how can it get any bigger? And you can check others to see that you don't. When you're in this form, I'm pretty sure this is the biggest one. Now I'm not rigorously proving it for you, but I'm fairly certain. And you can't go much past 19. Now maybe you can get to 23 squared. Maybe I don't even think you can get to 23 squared because it's larger. Then 19 squared is 361, right? And so that's gonna leave too much left over. So I think 19's, this is about it as far as this form, I think. So I thought I was done. But then it occurred to me, again, this was my original circled answer. Okay, but then guess what? There is another possibility that just occurred to me kind of at the last minute. For your d of n is equal to 8, we have these forms. And again, I just wrote this in. I'd only considered this form at first. But so we're doing the 8 business. And the way you can get 8 is right here. Remember, this would be, these are all prime. So this is p to the first, p to the first, q to the first, r to the first. And when you ink those things and multiply, you get 2 times 2 times 2 equals 8, right? And similarly for the rest of these. Now, y'all, I won't go through, I didn't explore this quite as much as I should have, but I did look at this one pretty carefully. And there's a very simple form right here that's very easy to believe. If you just think of 2, which is prime, times 5, times 97, right? All 3 of these are primes. This object, this number has 8 divisors, all right? So this is equal to just manifestly 970. Okay. And this right here is certainly bigger. So let me double circle that. Okay. So that's the answer I got, folks. Now, again, I tried with this one a little bit, but I never could get anywhere near this. In fact, I don't even know if I could get to 900 with this one. This one is very clear that it doesn't work. You can, 2 to the 7th is 1/28, right? And after that, it's well beyond. Okay. 2 to the 7th is 1/28. And then 3 to the 7th is certainly much greater than 1,000, right? So we don't have to even spend any time on this. Now this one, I haven't really, this is the biggest one I found. And I tried various combinations of this. I won't share that with you, but I didn't get anything very close to this when I was doing this one. So again, this is what I propose as the answer, 970. And I'm going to go ahead and write it down without declaring that it's formal in any sense. It's sort of rigorous what I've done here, listing the possibilities, but you always think maybe I'm leaving something out, you know. So n equals 970 is the answer I got. Okay, that's all.